before our break, we did a lot of integration. Okay, we're going to drop that for today, but we'll go back to it pretty soon here. All right, so I wanted to talk to you guys about integrating this. All right, this is just a review question. You guys have your formula sheets out? Okay, pull out your formula sheet. Do you have anything on your formula sheet? If you don't have your formula sheet online, go into resources and there's a copy of a formula sheet there you can fill out. Do you have any on your formula sheet the integral of 1 over cosine squared u? Anything like that on your formula sheet? No. Okay, which means I'm wondering what I can do with this problem, because if I make this u equal to 3x, I'm going to get 1 over cosine squared u. I'm not sure that that's going to help me. Anything I can do to this, guys, that will make it maybe something on my formula sheet? Ryan, what do you think? Change it to secant squared. Isn't 1 over cosine x equal to secant x, right? Which also means that 1 over cosine 3x is equal to secant 3x. And it's an identity, which means whatever this x is, you can replace it with whatever you want, okay? And which also means that if I square this side, it's equal to the square of this side. So 1 over cosine squared 3x is actually equal to secant squared 3x dx. Okay. Now when you look at your formula sheet, is there anything in your formula sheet that says secant squared u? You see secant squared u in your formula sheet. Yeah, what is it? Tangent u. Now be careful. You can't just say this answer is tangent 3x. This is not an identity. Okay, it's actually a formula. Okay, and so what you have to do is say, hey, if this is on my formula sheet, that's what my u is going to be. U is going to be equal to 3x. That means du dx is equal to 3. That means dx is equal to du over 3. Let me just write here. Most common wrong answer, okay, is going to be tangent 3x plus c. That's wrong. Okay, let me show you why. What two things do you substitute here? Your u and your dx and your u. Okay, so let me circle them. So there's my u and there's my dx. Okay, let me substitute this in. This would be secant squared u. My dx is du over 3. This should be something on my formula sheet or an easy antiderivative. On my formula sheet or an easy antiderivative. It's not quite on my formula sheet. What can I do to make it on my formula sheet? Pull out the 1/3. Okay, do you guys see that is on my formula sheet now? So this answer is 1/3 tangent u plus c. And that is a great answer. Do you notice that if you just substitute it right in, that I would have missed the 1/3? Do you guys see that? Okay. And then finally, guys, this is a great answer, but it's not the right answer. What do I need to do to make it the right answer? Replace the u with 3x plus c, 3x, and that is the right answer. Okay? All right, let's do this problem over here, the ln of x. Go look on your formula sheet. Go find the integral of ln of u. Go find that. Integral of ln of u on your formula sheet. You don't have it. Did you notice that? Okay, I sent you on a rat race. You don't have it. Why don't I have it? I could have sworn last year I learned the integral of ln of u. Everyone thinks they learned this, but they didn't. Actually, you will in a few weeks. Okay, and when you do learn it, you're going to wish you didn't have to learn it. Okay, this is not actually on your formula sheet. The integral of 1 over u du equals ln of u plus c. Is this on your formula sheet? Okay, this is on your formula sheet, but never on your formula sheet do you have an integral of ln of u. Okay, so make sure you realize that. Okay, so when you have an integral of ln of something, then your u is actually, well, let's see what it could be. Let me try to make my u my x. I'm going to make the entire bottom my u. Do you remember the shortcut? If I make the entire bottom my u, what's the derivative of x? 1. Do all my x's cancel out? No. So it's not an integral of 1 over u du problem. All right, that means this is not my u. If this is not my u, what else could be my u? Ln of x. Let's try it. Make your u equal to ln of x. Okay, and guys, even if you're not sure what to do, you can go through the algebraic motions And a lot of times things will just come out. All right, so I know that u is equal to ln of x, or I want to set u equal to ln of x. What's the derivative of ln of x? 1 over x, okay? That means dx is equal to x du. Are you with me so far? Okay. A lot of times this is a fraction, like over here it's a fraction, but it's not a fraction all the time. So I replace two things. What two things do I replace? My u and my dx. Okay. If you guys are consistently getting the wrong answers on these integration problems, try circling your u and your dx. Okay. And that way you'll be less likely to make a mistake. All right. So I'm going to replace two things. I'm going to replace my dx, I'm going to replace my u. Everything else I leave the same. All right, do my x's cancel out? Yes, and that's actually a very good sign. My x's cancel out, so what I get is the integral of u fifth du. Is this an easy antiderivative or something on my formula sheet? Actually, it is an easy antiderivative, and that is a great answer. It's just the wrong answer, because you need to go back and replace your u. And even though it's a little bit awkward to replace your u this way, that's how you do it. Okay? Any questions about that problem? All right, let's go ahead and see if we remember the derivative of logs, how to do this. If I want to take the derivative of 4x times ln of 3x plus 7, do you guys see which rule is operations on the outside here? Which rule is that? Product rule. Because I have an x expression on the left and an x expression on the right. I'm multiplying them together. Going to be the derivative of the first times the second. Leave that alone. Okay. Plus the derivative of the second. What's the derivative of ln 3x plus 7? Remember that? U prime over u. Okay. Times the first. And this is pretty much my answer. I'm going to simplify it. This is a 3. I'm going to simplify it by multiplying this numerator together. Because remember, numerators bounce out, but they can also bounce back. So that's 12x, 3x plus 7. And that's pretty much as reduced as I can get this. All right, any questions on our review? You guys feeling warmed up? Okay, this is something that from last year. So let me pull through. Okay, I want to talk about inverses for a while. So let's go to your notes. Okay, so let's talk about inverses. There are some things that you learned in pre-calculus or maybe with algebra 2 about inverses. You may or may not still remember it, but let me remind you of what inverses are. Okay, if a function has an inverse, so let's just say e to the x, that its inverse is ln of x. Okay, if a function has an inverse, when you graph them, some incredible things are true. One is the two functions are actually symmetrical about y equals x. Did you know that? I mean, think about the most common inverse function you might think about is squaring and square root, right? If you square and square root. So if I think about squaring x squared, I take x and I square it, okay, I get something that looks like that. If I take this and I'm probably not drawing this right very well, but if I take this and I flip it over y equals x, and I'm actually not drawing this well. This should actually go a little bit over like that. Okay, then the inverse will look like this. Sorry, I want to do a different color. So the inverse will look like that. Do you guys see what I'm doing? I'm flipping it over y equals x. But there's a little bit of a caveat. Inverses have to be functions, okay? Because we call them inverse functions, okay? So remember what a function is? It has to pass the vertical line test. Do you remember the vertical line test? You run a vertical line through it, and it can only go through one point at a time, okay? So do you see that this is a function, right? And this is a function. Everybody good with that? I mean, they're two separate functions, okay? Do you agree that x squared is a function? Okay, but do you see this? Is this a function here? No. So whenever you have something that passes a vertical line test, to make sure it has an inverse, it actually has to also pass the horizontal line test, okay? It has to pass both to have an inverse. So this actually does not have an inverse, because this, even though I'm saying it's its inverse, This is not an inverse function, so it doesn't count as an inverse. So if you have x squared, you actually have to remove this portion of it, like restrict the domain, so that you don't have this part. So then do you see that this passes the horizontal and vertical line test? You see that? And if it does pass both, then its inverse will pass, will be a function. It will pass the vertical line test, okay? This one is not a problem because this one passes both the vertical and horizontal line test. And so therefore its inverse will pass both of it, okay? And so we call these inverse functions. And so inverse functions have to be monotonic. Do you remember that word? Has to be monotonic. So this must be either strictly increasing or strictly decreasing to have an inverse. And so do you see how this was decreasing and then increasing? That's why it didn't have an inverse. Okay, it has to be monotonic, okay, to actually have an inverse function. Those are things that will be helpful to you in college definitions, but as far as this class is concerned, they'll always give you a function that has an inverse to do these problems, okay? Something else about inverse functions, though, that you may or may not know, is that if I have a point here, this point would be 0, 1, do you agree with that? There's always a corresponding part that's 1, 0. Did you know that on the inverse? So if this is 0, 1, I also have a 1, 0 somewhere on its inverse. Okay, so for example, if I said that this was 1e, wouldn't that be 1e? That means there's a point here that's e1. Okay, they always have what we call corresponding points. And this is going to be super important to us as we do derivatives of inverse functions. Okay. The other thing that's interesting about inverse functions is the domain of one is the range of the other, and the range of one is the domain of the other. So, for example, this one's domain is greater than 0. No. This one's domain is negative infinity to infinity. Do you agree with that? The x values, right? Okay. But this one's range is negative infinity to infinity. You see that? This one's range is greater than 0. This is y greater than 0. But this one's domain is x greater than 0. Do you guys see what I'm saying? Now that's also something good for college, not something that we're going to stress here in calculus. Okay, but something good for college for you guys to know also. All right. What you do need to know is how we develop the formulas. So let me talk to you guys about inverses real quick. If I tell you that f and g are inverses, so let me see if I have a screen that I've already put this in. Okay, if I tell you that f and g are inverses, and I'm looking at your second page on your notes, right below the box, okay, I'm going to develop the formula that's in the box for you. That formula that's in the box is also on page 2 of your formula sheet that you're going to have to enter in. So if you look at the second page of your formula sheet, you have something that says the derivative. If f and g are inverses, then I think g prime is equal to something. I'm going to develop this formula for you. Okay. Do you remember what I said? If there are inverse functions, like let's say you have a Nerf gun, okay? If you square it and square root it, then you get the Nerf gun back, right? Because those are inverse functions, okay? And so what happens is if f and g are inverses, if you square it and then square root it, the x is going to come back out. So do you remember learning this in, I think, Algebra 2 or Pre-Calc? Do you remember learning this? The same, you could also say this. Like this is equal to this is equal to x. If f and g are inverse functions, okay, this is something true. So I'm just going to start with this f of g of x. Do you agree that this is a composite function? And of course, this is calculus, so we're going to do derivatives. But what I'm going to do is take the derivative of both sides. Okay, and I just need to be consistent. So I'm going to take the ddx of both sides. Okay, on the right side, do you agree I'll get 1? Right, the derivative of x is 1. On the left side, do you see that that is actually the chain rule? Right, the derivative of a composite function. Well, what's the derivative of f of g of x? Well, that's f, leave the inside alone, f prime of g of x, leave the inside alone, and multiply by the derivative of the inside. Let's get with that, okay? So if I try to solve for g prime of x, the derivative of g, isn't that equal to 1 over f prime of g of x? Look at that. And that is the formula I need you to write down, okay, in your formula sheet. And I'll explain this formula in a second. It's actually a very easy formula to understand, but it's actually very hard when you look at it this way. So write this down in your formula sheet on page 2, guys. This is a formula you need to know. So if f and g are inverses, then g prime of x is equal to 1 over f prime of g of x. And likewise, f prime of x is going to be equal to 1 over g prime of f of x. Okay, I mean, they're basically the same. G and f are inverses of each other. Okay. All right, so what does this mean? Let's go look at this function, x cubed plus 1. So I'm going to move to this function here, x cubed plus 1. All right, so what I'm going to do is I'm going to find the derivative of f and the derivative of its inverse, okay, and look to see what happens. Okay, so first of all, let's graph x cubed plus 1. Okay, so I'm going to graph f first. So I'm going to graph f of x is equal to x cubed plus 1. So if I put in 0, I will get 1. So I have a point right there. If I put in, let me put 1 here, 2, 3. Actually, I'm going to put it a little bit closer. 1, 2, 2, 4, 6, 8. And then here, I'll put in 2, 4, 6, 8. Okay, this is wisdom from last period. All right, if I put in 0, do you see I'll get 1? So I'll put a point right there. Okay, if I put in 1, do you see I'll get 2, right? If I put in, what number do I want to put in? If I put in, how am I going backwards on this? Let me put in 2. If I put in 2, do you see I'll get 9? Okay, everybody good with that? Okay. If I put in -1, do you see I get 0? If I put in -2, I'll get -7. Let me go -7 here. -2, -4, -6. So -7, right? Yes. All right. So I'm going to graph x cubed plus 1. I'm just going to connect these dots. I kind of know what x cubed looks like. And it just gets shifted up 1. Yeah, good with that. Okay, so this is my f graph. I'm going to label that f. Okay, what I'm going to do is I'm going to find the inverse of f. Okay, so I'm going to call that g. I'm going to say f and g are inverses. Okay, to get the inverse of this, actually, let me just call this y. I'll call this y. I graphed y equals x cubed plus 1, and that was my f function. Now I'm going to do the inverse of f. Guys, inverse of f has a notation. It's f to the -1. Do you guys remember that from Algebra 2 or pre-cal? Okay, be careful. This is not 1 over f. Is everybody good with that? Okay. When it's a name of your boy, okay, if it's a name of the function and it's -1, that's an inverse function. It's just a notation. It's not the same as 1 over f. Whereas if you have like 3 to -1, that's 1/3. Does that make sense? Okay. Because 3 is not the name of your function. Or if you had x to -1, a lot of times that's 1 over x. Okay, but x is not the name of your function. If your name of your function to -1, that's not equal to 1 over f. Okay, you guys good with that? So make sure you understand notation. All right, so I'm going to find the inverse of this, which is basically you switch these, right? You switch your x and your y, okay? And that's how you find inverse functions. So I'm going to solve for my new y. So y cubed is equal to x minus 1. So y is equal to the cube root of x minus 1, okay? So this is what f to the -1 is, and this is what f is. Okay, I'm going to, well, I'll just leave it f to -1. Okay, so I'm going to graph this inverse function. Okay, so to graph this inverse function, let me just plug in, okay, if I plug in 0, you see I'll get -1. Okay, so let me go ahead and plot that. So 0, -1 is right here. Okay, if I plug in 1, you see I'll get 0. So let me put in some points. 0, -1. If I plug in 1, I'll get 0. If I plug in 2, what do I get here? Are you guys getting 1? Plug in 2, I get 1, right? If I plug in 3, that's not really going to work out very well. Let me plug in 9. If I plug in 9, what will I get? 2, right? The square root of 9 minus 1, I'm sorry, the cube root of 9 minus 1 is that, which is 2, okay? And so let me put some points here. This is 9, 2, this is 1, 0, this right here is 2, 1, I believe. Okay, so let's look at points. This red point up here, do you remember this point? Wasn't that 2, 9? And wasn't this point right here, wasn't that 1, 2? And this point here, wasn't that 0, 1? And remember, inverses have corresponding points, right? So if I have a 2, 9, then I have a 9, 2. If I have a 1, 2, then I have a 2, 1. If I have a 0, 1, then I have a 1, 0. Okay, this point down here, was it -2, -7, right? So that means I also have a -7, so -6, -7, -2. Okay, so I can connect all of these points. I actually intended to do it in blue, but red is fine. Okay, and this one's the inverse. Okay, this one right here. And is it flipped over y equals x? Is it symmetrical about y equals x? Yes, so I know I did the right thing. Let me go ahead and label these. This one right here is my f -1, and this up here is my f. Okay, now something interesting about inverse function derivatives at the same point. So let me make sure we understand this. I'm going to grab the derivative right here at 1, 2 and at 2, 1. So those are these two green points here. I'm just going to observe the derivative at these 2 points. All right, what's the derivative at point 1? The derivative at point 1, what does that mean? That means if I got the slope of the tangent line here, what would it be? Okay, so I know f is equal to x cubed plus 1. I know y is equal to x cubed plus 1. So that means y prime, or f prime, is equal to 3x squared plus, no, just 3x squared, right? And so that means f prime at 1 would be 3 times 1, which is 3. Everybody good with that? So let me write some things that I know. Right here at this point, and I know my paper is like a little bit messy. Right here at this green point, okay, there's 2 things I know. The first thing I know is f at 1 is equal to 2. And the second thing I know is that f prime of 1 is equal to 3. If you agree with me so far, at that point, the f of 1 is equal to 2, and f prime of 1 is equal to 3. And what I want you to note is this, because students start to get confused about this. This number right here represents your x, right? Isn't that the x value of the f? This number right here, doesn't that still represent my x? Isn't that the x value of my f? Even though it's a prime here, aren't the ones both x values? Do you agree with that? Okay, so let's keep moving on. This derivative right here, if I did a slope of a tangent line, what would that slope be? Okay, I'm going to tell you, because of my formula, it's going to be 1/3. Whatever this is right here, okay, as long as these are corresponding points, and these 2 functions are inverses, then the answer is just the reciprocal of this. So what I'm going to say is f at -1, actually, I'm not going to call it this. I'm going to call it g, because f at -1 is super confusing. And then we're going to take the derivative of it, so it's going to look like this. Okay, it's going to look like a mad animal. Okay, so what I'm going to do is I'm just going to call this g. Okay, and actually you're going to see me do that throughout all the worksheets. Okay, so f of -1 is equal to g. So let's just say this function is now called g, and f of g inverses. Okay, then what I'm going to say is g at 2 is equal to 1. Do you agree with that? And g prime at 2 is equal to 1/3. Is everybody good with what I'm writing so far, just notation wise? Okay, this is formula. Okay, I got this from the formula that you just wrote down on your yellow sheet. Okay, but let me tell you, let me test with you and make sure it's true. Because you don't want to just believe everything I say. Let's just make sure it's true. If I go take this y right here, because this is my derivative, this is my inverse. So for the inverse formula, y, let me just call it g. G is equal to x minus 1 raised to the 1/3. Do you agree with that? The derivative of this is 1/3 times x minus 1 raised to -2/3 times the derivative of the inside, which is 1. Do you agree with that? I'm taking the derivative of g. Okay. And if I keep on moving, okay, I want g prime at 2, right? I'm trying to prove that this thing right here is actually 1/3. Well, that means everywhere there's a x, I'm going to put in 2. So this is 1/3. If I put in 2 there, I get 1 raised to negative 2/3 times 1. And do you see that that is actually 1/3? Okay. So all this suffice to say that if you look at two functions that are inverses of each other, if you look at the corresponding points, the derivative of one is equal to the reciprocal of the derivative of the other. You guys good with that? Okay, so it's going to start to get confusing, so I want to clarify some things with you. Do you see that these points are 1 here and these points are 2 here? You guys see that? Do you see that this is the x value of my g? I have it covered here. Let's see if I can move it. Do you see that this 2 is the x value of my g function? This 1 is the x value of my f function. Okay, but do you also see that this 2 is the y value of my f function, and this 1 is the y value of my g function? Is good with that? Okay, so let's move on and do some example problems. I think you'll like the example problems better. Now, I need to warn you about something though. These problems are super fast to do, okay? But you really only do it 2 ways. You either do it fast right or you do it fast wrong, okay? So let's see if we can do that. It's really easy to put the wrong number in and just get the wrong answer. Okay, this one's going to start off a little bit easy, and then we're going to get a little bit tougher and tougher. But they don't really get super tough, except a lot of times you accidentally put in the wrong number. All right, f and g are inverses. Okay, actually, f and f negative 1 are inverses. Everybody good with that? Guys, every time I see f to negative 1, because it's f to negative 1 prime, this is super confusing. So what I do is I change this to g prime, and I put on this side here, f of negative 1 is equal to g. You can do it on the AP test too. You just redefine it. As long as you're consistent on your redefinition, you're okay. If you want to continue to use f of negative 1, I have no problem with that. I just want to make sure you guys understand. I change it because it gets super confusing. Okay. All right. Then what we're going to do is we're going to say, I want to find g prime of 5. So I write it down. Then I write my formula. If f and g are inverses, which they are, because f and f of negative 1 are inverses, okay, and g is f of negative 1, then this is equal to 1 over f prime times f prime at some number. Okay, and this is just the formula on my formula sheet. All I did was write the formula. Okay, now remember though, if this is the x value, this is the y value of this. You gotta remember these are coordinating points. Okay, so I need to figure out what this x value is of the f. Okay, so let's think about this. I always draw on the side a little picture of my coordinating point. Okay, I make it look like this. You can draw it any way you want, but I always put 2 points here just so I don't get confused. And I write down which number I know. Okay, so do you see this 5? Now here's a tricky question. Is it the x value or the y value of the g? It's actually the x value. Okay, why? If you go back to where we were originally with the x cubed plus 1, go look at that problem. That number in parentheses was always your x value of that function. Okay, so this 5, even though there's a prime here, this 5 is the x value of your g. So you put the 5 there. But guess what? If this is 5, where else is there a 5 here? The y value of the f. Okay. Now, do you see right here, what I'm trying to put in this slot is the x value of your f. You see that? This right here is going to be the x value of your g. Okay, so let's go find the x value of my f. Do I know what it is given what I'm given here? You see where I'm getting that 3? Okay, because that was given to me. Right here it says if my y value of my f is 5, then my x value is 3. And guess what? I know also that is 3. Okay, and guess actually what else I know? That is 3. Okay, and now it's just a fill in the blank. What is f prime of 3? If I could figure out f prime of 3, I just divide it by 1 and I'll be good. So what is f prime of 3? Okay, so this is 7/2. Be careful. This is 1 over 7/2. So the answer is 2/7. You see how easy that is? Okay, but easy in the math, but hard on putting the numbers in the right place. Okay, so let's do another one. Okay, they're telling me that f and negative 1 are inverses. Once I see an inverse with derivatives, I change this right away. Okay. Okay, let me actually rewrite it. I always just put G prime 2. Like I just rewrite it. That's what I want to find. Okay. The reason is because this -1 and the prime gets super confusing. You start to think -1 is prime and the prime is an inverse. Okay. All right. Make sure you redefine it though. I've redefined it on the side here, and then I write my formula. Okay. And a lot of students, the reason they have trouble is they don't write their formula. Okay. Write your formula. Because if you can fill in this formula, you're done with the problem. I mean, you're actually 50% of the way here just writing your formula. All right. So here's what I have. I just need to know, this is the x value of my g, okay? And this is going to be, I'm trying to find the x value of my f. Okay, so let me go ahead and draw my little picture here. There's my f and there's my g. I have two corresponding points, all right? This is the x value of the g. So I'm going to put a 2 there. Okay, if this is the x value of the g, then that's the 2 is actually the y value of the f. You guys good with me so far? These are called corresponding points, right? Okay, how do I find the x value of my f? Go to everything that they've given you up here. Where would I plug this 2 in? This is where students get confused. Is this 2? Yeah, Ryan. No, so here's the question. Would I sub it in f of x or would I sub it in an x? F of x, very good. Okay, so I'm going to change this to 2. So what I get is 2 equals x cubed plus 2x minus 1. And guys, do you notice on the right side how it doesn't factor? I mean, I don't know if it does. It doesn't factor very easily to me. Okay, and you're not going to get a calculator on these sort of problems. So we're going to do what you guys do on your tests. We're going to guess. Okay, you guys are good at this. I know. I grade your tests. Okay, so here's what you want to do. You're just going to guess. The answer is always 0, 1, 2. The hardest might be -1, -2. Okay, it might be 3, but usually it doesn't even go that far. How do you know to guess and check? It's usually these type of problems. It's usually the derivative of the inverse, and you can't factor it. Okay, so let's figure out how to solve for x here. You're not going to have a calculator, so again, just try 0. If I plug in 0, is that true? Is 2 equal to -1? No. Okay, so if this is x equals 0, it didn't work. Okay, try x equals 1. That'll be 2 equals 1 plus 2 minus 1. Does that work? Yeah, it actually works. Okay, so x is equal to 1, so I'll put 1 there and 1 here. Okay, and once again, when you guys are doing it on your homework and you get frustrated, just remember, you can guess and check. Okay, whenever it doesn't factor, just guess and check. All right, so I'm going to put a 1 there. Okay, now what's f prime of 1? Can I figure that out? Yeah, remember this is my f. I know how to find the derivative. F prime of x is 3x squared plus 2. What's f prime at 1? That's going to be 3 times 1 plus 2, which is 5. So what is my final answer, guys? Be careful. It's not 5, but it's 1 over 5. Okay, so sadly enough, some students would say the answer is 5. And I'll just take a point off because you did most of the math right, but you need to make sure you understand the formula. It's 1 over 5. Okay? You guys good with that problem? Okay, let's do another one. Actually, you guys do this one. I thought you guys can get it now. Okay. We have g and g prime of -1. I don't like this g prime of -1, so I'm just going to change it. Just make sure on the side I define what g prime of -1 is. Okay, you guys work it from here. The good thing about these masks is that you don't have to cover your mouth, really. You just blow through them. Okay, write the formula first. That's what I would do. Write the formula. The x value is 2. The x value of my f is 2. Did you guys use that? So that means the y value of my g is 2. You have to solve for x here. You actually don't have to guess and check. You can actually solve here. This would be 4 is equal to x plus 1. So I get x is equal to 3. Okay, so hopefully you guys got 3 for your y value of your f. So 3 goes there, 3 goes there, and 3 also goes there. Did you guys get that far? Okay, so all I have to do now is find out what g prime of 3 is. So given everything that I'm given, I know that g is equal to x plus 1 raised to the 1/2. That means g prime is equal to 1/2 chain rule times x plus 1 raised to negative 1/2 times the derivative of x plus 1, which is 1. But I don't want g prime of x. This is really g prime of x here. I want g prime of 3. So that means everywhere there's an x, I'm going to put in 3. So this is actually 4 raised to negative 1/2, but that's really 1/3 times the square root of 4. So did you get 1? No, that's not right. Is this a 2? Yeah. So did you guys get 1/4? Okay. So this is, careful, this is 1/4 on the denominator. So what's my whole answer? 4. How comfortable are you guys feeling with this? It's not bad if you put the numbers in the right place. But again, if you just get one number wrong, it messes you totally up. All right, let's do a cosine problem because you guys hate sine and cosine. All right. That's the only reason I do it, to annoy you. Okay. So once again, I've got inverses and derivatives. Anytime you see that, I just think f and g are inverses. So I change this to g. F and g are inverses. And on the side, I redefine what f to negative 1 is. I call it g. Okay. All right. So I write my formula down. My formula is g prime f squared root of 3 over 2. That's going to be equal to 1 over f prime of something. It's good on like writing the formula. Okay. So remember, this is the x value of my g. This is going to be the x value of my f. So let me go ahead and draw some dummy graphs here. Okay. Which point do I know? Which point do I know? Where does it go though? It's the x value of my g, so that goes right here, square root of 3 over 2. But that also means it's the y value of my f. You guys see the switcheroo here? Okay, don't let the switcheroo trick you. That's why I draw this fake, graph, because it actually helps me a lot just visually to see what's going on. So what I know here is my y value of my f is square root of 3 over 2. So the most common thing students do wrong is they plug in x equals square root of 3 over 2. You guys see that? But it's not x equals square root of 3 over 2. It's f of x. So this is square root of 3 over 2 is equal to cosine x. Okay. Guys, what cosine or what angle would I get square root of 3 over 2 for my cosine value? Remember, cosine's x. Okay. Yeah, so it's over here or here. But they're giving me, I have to be between 0 and pi. So do you see x is equal to pi over 6? You see, you also need to know the unit circle pretty well. Okay. All right, x equals pi over 6. So what that means is this is pi over 6, this is pi over 6, and this is pi over 6. Everybody good on why did I find pi over 6 and where do I put it in? Okay, well, if I could just figure out what f prime of pi over 6 is, it's really just plugging into this formula. I know that f of x is equal to cosine x. What's f prime of x going to be equal to? Negative sine x, okay? But I don't want f prime of x. I want f prime of pi over 6. So that's negative sine of pi over 6, which is that negative 1/2? Is that right? Okay, so if this is negative 1/2, be careful. I'm going to take the reciprocal of negative 1/2. What's that? Negative 2. Guys, the negative is still there when you take the reciprocal. Okay? All right, let's have some fun. I'm going to skip the next problem. I'm going to go down to the graph. Just because I think that the rest you can really do by yourself, but the graphs, oh, you can do it by yourself if you haven't seen it yet. So let's do a graph down here. Not a graph, a table. Okay, let's look at this problem here. This is like a few problems in one. All right, they give you a table and they ask you to find g prime of 2, and you know that f and g are inverses. They have to give you that, or else you can't work this. Okay, so I'm just going to start with the formula. If I'm trying to find g prime, do you agree that's 1 over f prime? Right? If I'm trying to find g prime, do you agree that that's 1 over f prime? And once again, if I'm trying to find g prime, do you agree that that's just 1 over f prime? Right? Oops. Okay. And so I'm going to go ahead and draw my little help here, draw my little picture. So just for the first one here, g prime of 2, okay, put in your coordinate points. Okay, this is the x value of the g. You guys see this? The 2 is the x value of the g. So this will be 2 comma something, which makes the f here something comma 2. Okay, so I'm going to try the x value of my f. Any idea what the x value of my f is if the y value of my f is 2? Are you guys getting 6? Okay, so I'm going to put 6 here, and 6 here. And what's f prime of 6? 1/2, but be careful. What's 1 divided by 1/2? 2. Does everybody see how that works? Okay. You guys do g prime of 4. See if you get the same answer as me. Did you get -1 for g prime of 4? Okay, good. You guys should check me on this too. And then g prime of 6, see if you guys can do that. Did I get it right, guys? Those you guys who did it? Yes, okay, thank you. Okay, let's take a break a little bit. Let's move to the right side. You guys can write down your answers if you want to check it later. How do you find g of 6 though? What's g of 6? Did you guys get it? Did you get 10? Okay. How did you do that? Well, it was part of this problem for one. But what you would do is you would draw an f and a g, right? You would say, hey, your x value for your g is 6. Okay. That would mean, since these are corresponding parts, because f and g are inverses, your y value for your f, is 6. Okay. And so then you go look up here and you say, all right, if my f value is 6, what is my y value? 10. Okay, so that's why I got 10. All right, so what if they ask for g of 0? You'll do the same thing. You draw an f and a g, and this should be easy because it's not derivatives, but it's kind of hard because you're so used to doing derivatives. All right, Mateo, are you with me? All right, so this is, guys, is this the x value or the y value for your g? X, so everybody get that? It's always the x value. Even if it has a prime, it's always the x value. So this is going to be 0 comma something, which means this is something comma 0, right? If your f value is 0, what is if my y value for my f is 0, what's my x value for my f going to be? 8. So I put an 8 there, an 8 there, and an 8 here. Everybody good with that? All right. And then let's do the last one, f and g. If your x value for your g is 1, and that means your y value for your f is 1, you go look in the table. If the y value for my f is 1, what's the x value for my f? 4, 4, 4. Everybody good with that? All right. You guys are armed and dangerous. Go ahead and start on your homework. I'm gonna go ahead and walk